Plant-based fats, particularly those found in nuts, seeds, and certain plant oils, are emerging as powerful modulators of the gut microbiome, offering benefits that extend far beyond traditional heart health. Clinical trials and emerging research suggest that these fats, primarily monounsaturated MUFA and polyunsaturated fatty acids PUFA, interact with microbial communities in unique ways, influencing the abundance of beneficial bacteria, the production of health-promoting metabolites, and systemic metabolic signaling. Unlike saturated fats from animal sources or highly processed oils, plant-based fats appear to foster microbial diversity, promote short-chain fatty acid (SCFA) production, and reduce inflammation, highlighting their critical role in both gut and whole-body health. Nuts provide a particularly compelling case study in the interaction between plant-based fats and the microbiome. Pistachios, almonds, and walnuts are rich in MUFAs and PUFAs, alongside fiber, resistant starch, and polyphenol, creating a nutrient matrix that encourages the growth of SCFA-producing bacteria such as Faecalibacterium prosnitziae, Roseburia, and Bifidobacterium. These microbes ferment dietary fibers into butyrate, propionate, and acetate, which support gut barrier integrity, reduce systemic inflammation, and improve metabolic signaling, including insulin sensitivity. The combination of fat and fiber in nuts appears to amplify SCFA production, creating a synergistic effect that is absent when fats are consumed in isolation, such as from processed oils or fatty meats. Clinical trials comparing nut-based interventions with diets high in animal fats or refined oils show striking differences in microbial composition. Diets rich in saturated fats tend to favor the growth of bile-tolerant, pro-inflammatory bacteria such as Bilophila wadsworthia, which have been linked to increased gut permeability, endotoxemia, and systemic inflammation. In contrast, nuts' unsaturated fats, combined with fibers and polyphenol, encourage SCFA-producing and anti-inflammatory microbial populations. These shifts are associated with reductions in inflammatory markers like interleukin-6, IL-6, and C-reactive protein, CRP, improved lipid metabolism, and better glycemic control. Even when total fat intake is similar, the source and composition of fats matter. Plant-based fats from nuts actively promote a gut environment conducive to health, while equivalent calories from animal fats or refined oils do not provide the same microbiome-driven benefits. The polyphenol naturally found in nuts also interact with the microbiome in ways that complement the fat profile. These compounds are metabolized by gut bacteria into bioactive phenolics that reduce oxidative stress, modulate inflammatory pathways, and encourage the growth of beneficial microbes. For instance, pistachios' polyphenol selectively enhance populations of SCFA producers, further increasing butyrate availability and reinforcing gut barrier integrity. This creates a dual mechanism. Unsaturated fats help maintain favorable microbial diversity and bile acid metabolism, while polyphenol provides substrates that selectively enrich protective taxa, together creating a robust microbiome that supports systemic health. Another important advantage of nut-based fats is their effect on bile acid metabolism. Unlike saturated fats, which can increase the production of secondary bile acids linked to inflammation, MUFAs and PUFAs from nuts are metabolized in ways that maintain bile acid homeostasis, reduce gut oxidative stress, and support microbial balance. This is crucial because bile acids act as signaling molecules that influence energy metabolism, glucose regulation, and lipid handling. By fostering a microbial community that processes bile acids efficiently, nut-based fats indirectly contribute to metabolic resilience, enhanced insulin sensitivity, and lower systemic inflammatory tone. Timing and integration of plant-based fats further enhance their benefits. Consuming nuts as part of meals or snacks ensures that their fibers and polyphenol reach the colon alongside unsaturated fats, maximizing microbial fermentation and SCFA production. Evening consumption, for instance, can support overnight microbial activity and metabolite production, creating a favorable internal environment for glucose regulation and reduced inflammatory signaling by morning. Clinical trials indicate that even modest daily portions, roughly 20 to 30 grams of nuts, can shift microbial composition toward more favorable profiles, demonstrating that small, consistent dietary choices can yield measurable improvements in gut and metabolic health. Beyond metabolic effects, plant-based fats in nuts contribute to satiety, energy stability, and cardiovascular health. By slowing gastric emptying and moderating postprandial glucose excursions, MUFAs and PUFAs help prevent late-night hunger and excessive calorie intake, supporting both weight management and long-term metabolic resilience. The microbiome-mediated benefits reinforce these effects, producing SCFAs that regulate appetite hormones like GLP-1 and PYY, enhancing feelings of fullness and reducing the risk of overconsumption. This demonstrates how nut-based fats act not only as nutrient sources, but also as functional foods that actively shape host metabolism through the microbiome. In summary, plant-based fats, especially those from nuts, offer a unique and potent way to feed the microbiome while supporting systemic health. Unlike saturated fats or processed oils, MUFAs and PUFAs in nuts interact with gut bacteria to enhance SCFA production, maintain gut barrier integrity, modulate bile acid signaling, and reduce inflammation. Combined with fiber and polyphenol, these fats foster microbial diversity, improve insulin sensitivity, and support cardiovascular and metabolic health. Emerging clinical evidence positions nuts not just as calorie-dense snacks, but as functional foods that actively cultivate a healthier microbiome, demonstrating that the quality and source of dietary fats can transform metabolic outcomes and optimize long-term wellness from the inside out.